Okay, we're going to study the flow source and the effort source. In this case, we'll study the block diagrams of the corresponding bond graph notation. For a flow source, like the one on the right-hand side, which is a velocity source, and the one on the left-hand side, which is an effort source. Okay, so here we go. Let's just put in here, this is the my voltage source. In here, let's say, we are going to say, this is called SE element. On this one, a flow source, we're gonna call it an SF element. Okay, so in this case, you have a voltage source. In the case of a voltage source, we have a very simple block diagram that we have a block in here where the variables are, you see the output from here is voltage and the source is your source of effort, or how do we call it in this case, the wall or the battery, any voltage source. um, let's just call it be like this, or this would be our source of effort like that. Either one of these notations would work. So how are the equations for this? This in the source is just that the voltage is this source of effort in here, like that. Very simple equation, very simple block diagram. If we have the, this is the block diagram. And if we do it the bond graph way, this is going to be an SE element like this, where we will have this kind of causal form, and this cannot change, doesn't have any other option, because this would be the effort variable, and this would be the flow variable. So this is, you could say, this is, in this notation, this is the variable E, and this would be the way we represent the bond graph model. So this would be your bond graph. So it's just a source, yeah? And in the other case, we have, this is a velocity source. Why is it a velocity source in this case? Or we are going to call it a flow source. And the one was called effort source, or this is called flow source. I'm just going to be consistent, put here effort source. And this would be the velocity source or flow source. So how do we represent these ones? We represent this by this symbol. Just get changing here so that this would be, in this case, the velocity is the what is provided to the system. So in this case, the velocity is the source of flow, You could write that velocity is that source of flow equal to the variable f. And now we need to represent that in bond graph notation. So if you have an SF like this, then it follows that you can produce this like that and have a flow source, because this is the velocity here, and then this would be the force. So this is the effort or effort, and this here effort, and this would be flow. So this this gives out a variable, a flow variable or velocity to the rest of the system, and so there's this notation for the we call it SF element, which the way we read it is, I'll remind you again. See this line that is always indicates the flow, and this line always indicates the. Which way is it? If you were to hold this just for make a figurative example and use it as a tool, it's obviously that you're gonna push it this way, right? And if you do this, the input to the element is the effort variable, and the output is the flow variable. So this is what comes out. This is what goes in. Yeah. So that way you can represent it this. You can understand this. In this one, you know, if you had your hand in there, you're going to push it this way. That means that the effort variable in here is produced by this, or this, in fact, it is that. That's what the source is. So that gives us an indication of the difference between the voltage source or effort source and a velocity source or flow source.